Hello and welcome back. A projectile is shot into the air. Its height from the ground is modeled by the equation negative 16t squared plus 64t plus 1400. Okay, and it says h equals these quantities. And typically when we see an equation like this, sometimes it'll specify this, sometimes it will not. If it does not specify, h is typically given in whatever unit you tend to use the most for distance. In the United States, typically that's going to be feet. So h would be in feet and time will be in seconds. If this were in a metric country, then we would assume the height would be in meters and the time would be in seconds. So given this information, we want to solve this problem. And we're asked two questions. A, find the maximum height of the projectile. And B, find how long it takes to hit the ground. Well, the first thing you need to realize is this is a quadratic equation. It's the highest term is a square. And so if you think of the quadratic formula, this would be A, this would be B, and this would be C. Okay? Remember the old A, negative B plus or minus B squared minus 4AC all over 2A, you know, all of that. So A would be the highest order term, B would be the middle term, and C would be the constant. And if you know that, then the vertex of the parabola will always equal x comma y, where x equals negative b over 2a and y equals f of x. Okay? This is true for any quadratic. The vertex, which if it is an upward parabola, let's look at this for a second. If it's an upward parabola, the vertex will be the minimum. If it is a downward parabola, the vertex will be the maximum. Well, when you shoot a projectile into the air, it's going to look like this. It's going to go up, reach a maximum, and come back down. Okay? That whole gravity thing always gets you. So this equation will look like this if it's graphed, and we're looking for the maximum, which will be the vertex. So let's find our x-coordinate. Okay? X-coordinate will be negative b, 64, over 2a, which will be 2 times negative 16. Okay, well, basically, what do we get? We get negative 64 divided by negative 32, which gives me 2. Seems easy enough. That's the x-coordinate. How about the y-coordinate? Well, the y-coordinate will be equal to f of x. So whatever you found for x, plug that in and that gives you y. So, okay, well, let's plug in 2 here. 2 squared is 4. 16 times 4 is 64. So we get negative 64. 2 times 64 is 128. And then plus 1400. What is negative 64 plus 128 plus 1400? That answer is 1464. Okay? Now what does that mean? That means that the vertex of this parabola, remember your x-axis will be time, your x-coordinate is 2, your y-coordinate is 1464. That means 2 seconds after the projectile is fired, it is at a height of 1,464 feet. Okay? Well, what did they ask for in this question? They asked for the height, which would be the y-coordinate. So the answer is 1464 feet. Okay? And if I ask you, how long did it take to reach the maximum height? That answer would be 2 seconds, because that's our x-coordinate here, or in this case t. How long does it take to hit the ground? Well, again, looking at a parabola, a downward parabola, if you were to graph this, it's going to look something like this. Okay? Your vertex will be here. And where does it hit the ground? It hits the ground somewhere over here. We're looking for this point. This is what we're looking for. Okay? And I ask you, go back to the original equation, what is the height when this projectile hits the ground? The height would be 0. So we have this equation, 0 equals negative 16t squared plus 64t plus 1400. And we're basically asked to find when the height is 0. Okay, well, it just so happens that I have a neat little quadratic here. And the first thing I always like to do is try to factor this. And you play with it for a little while and you'll find out it does not factor. Well, if a quadratic doesn't factor, the next best way to solve it would be the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I plug in the numbers from the equation. This is a, this is b, and this is c. Given that, I put these numbers in, I come up with negative 64 plus or minus the square root of, and I just go ahead and combine these terms. B squared will be 64 squared minus 4 times negative 16 times 1400. And when we put all that together, I get 93,696 under the radical. And that's divided by negative 32, because a is negative 16 and 2 times negative 16 is negative 32. And when I combine these, and this is t equals that, when I combine these, what I end up with is two answers. I end up with negative 64 plus this radical and negative 64 minus this radical. And so what I end up with, and I always like to do this, is you end up with 11.566 and negative 7.5656. Okay? Well, now, this answer here is intriguing. What that means is, if you go back to the original graph, if the ball was launched from the ground, it would have been launched 7.5 seconds before the original launch time, okay? Well, we're not concerned with what happened before our experiment started. We're concerned with what happened afterwards. And so this is what we call an erroneous solution. It's not useful in this case. The other solution says basically 11.5 seconds after the projectile is fired, height equals 0. Well, that's on the ground. So your answer is 11.566 seconds. Okay? So that's how long it takes for this projectile to hit the ground. If you have any questions about this, please come see me.